All right. Looks like we are on for Science Saturday. Welcome everyone. I know I'm not normally the one introducing us. Kitty's just waiting to sign on because she's coming in from the field today. As you can see, despite what you may think, I am actually not in the field. But we are going to be talking about mangroves this morning. So let me just see where Kitty is. Let's see. So while we wait for a little bit, I think it'd be really cool to show you guys a little bit of some of the tools that we have here in Science Saturday. And here's a part of what we're going to be talking about today. One thing that's really interesting that Howard, our guest, who's going to be talking about with us is using 360 photo and video. And so I can show you guys a little bit of what that actually comes out to look like, and a little bit of where Kitty and Howard are going to be today. Oh, there they are right there. So we just wait on Kitty to connect to the audio here. Kitty, can you hear us? Oh no, Kitty, now you're on mute.
Sorry, it joined on mute. So I was.
Well, can you hear us all right?
So little bit of bad news. I forgot the dongle.
Oh, that's okay. As long as you guys are plenty loud, I can hear you just fine.
Okay, so
I'm sure everyone else can too. So I've got everyone here, and I was just about to pull up a 360 video, but it looks like you guys could give us one as is.
Yeah.
So as you can see, I'm only pretending to be in the Mangrove Nursery.
Right.
But why don't you give us an introduction, where you are, who's with you?
Right. Well, good morning, everybody. Welcome to Science Saturday in the field. Like, we are in the field today in the mangroves. And I have behind me our team and an airplane. Oh my goodness. I hope that's not ridiculously awkward. So our team behind us is setting up for the Mangrove Nursery research we are going to be doing today. So I'm going to flip my camera around and start the introductions. And I think that our horizontal camera works for today. Yeah, cool. Perfect.
Yep, should be good to go. I'll let you know if it's a problem.
Cool. All right, so we are flipping. Look at that view, guys. Baby mangroves. All right, so we have with us our favorite junior scientist, Mason. Ayo. And leading us today, our fearless mangrove scientists, we have Howard and Zola and Javon. Ayo.
Morning. Oh, this is me now. I'm supposed to.
Yeah, you're talking. This is you.
Good morning, everyone, and thank you for joining us today on this Science Saturday adventure. As Kitty mentioned, we're going to be talking a little bit about the mangrove research that we do here at the university. So Kitty had shown you before, she panned the camera around. So she showed you some of the mangroves that we have on site. So these mangroves, they're all red mangroves. The scientific name for them is Rhizophora mango. And so these were all planted 3 years ago, immediately after Hurricanes Irma and Maria. So these are pretty much 3 years old, and really good news, some of them are flowering now and producing seeds, which is amazing. What's also important to note is that these mangroves that you see here, these were all seedlings that were collected from various parts around, not just St. Thomas, but also St. John and St. Croix. So here in this particular nursery, we have mangroves that are growing from different parts around I guess 3 of the U.S. Virgin Islands, St. Thomas, St. John, and St. Croix. And so we're hoping that today we'll kind of show you some of the work that we do, how we assess the health of the mangroves, and then maybe some other cool data things that we do while we're here in the field.
Awesome. Thanks so much, Howard. I got to say, this might go down as one of my favorite Science Saturdays ever because it is so pretty out here. Also, we're like, calf deep in water, chillaxing in the baby mangrove. It is a good day.
Unfortunately, so Kitty can't stick her phone in the water, but there are around us right now. So there's tons of fish. They're bait fish. I'm not a fish biologist. I'm trying to remember the names of all the fish. But there are some grunts, there's some yellowfish, and some other different types of fish.
There's some big fish and little fish and yellowfish and silverfish.
So just a question from me, you guys. So mangroves, can we talk a little bit about like what makes mangroves so different and so special? Just because, I mean, you guys are talking about mangrove trees, but you're in the water right now. I mean, that's pretty different compared to most trees, right? What is so
Correct.
different about mangroves?
Yep. So scientifically, we call mangroves halophytes. And so halo means salt and phyte means plant. So basically, a halophyte is a plant that is able to tolerate, it loves, it can withstand salt. And so that's what makes these plants pretty much unique and different from other plant species. You stick any other plant in salt water, it'll probably die.
I might be a halophyte. I love salt.
We love the seawater. And so each mangrove is unique in how it's able to deal with salt. And so what we'll do is we'll pan around and show you some of the ways red mangroves are able to deal with that. But basically what they do is they take all of the salt that would otherwise kill them and they dump it into one specific leaf, which is called a sacrificial leaf. That leaf eventually turns yellow, orange, brown, and then black, and then it eventually falls off the tree with all the salt in it. Black mangroves, on the other hand, they are able to take the salt and excrete it through the pores on the underside of the leaves. So you can basically wipe your finger on the underside of the leaf and you'll actually come up with salt crystals that you can then consume. And the white mangroves also have a similar way in which they deal with salt. But that's probably one of the most important things with these, but they also provide important habitat. So like I mentioned before, there's all these fish around. They're here because these mangroves are providing shelter for them.
That's super cool. So I think that before we start talking about the importance of the mangroves, can you show us some of those sacrificial leaves you're talking about?
Sure. There's actually one right behind you.
Smush, do you think you can find it? Sorry, Mason. Science assistant Mason, looking for the sacrificial leaf.
So remember, the sacrificial leaf is that one leaf that eventually starts to turn yellow, and then orange, and then brown, and then falls off the leaf. Yep, that's correct. So these are sacrificial leaves, and after time, after they've accumulated enough salt, they'll eventually fall off the tree, and you'll see some of them floating around in the water. And so they have a lot of organic material still left in them. So they're actually a really good nutrient source for the ecosystem here that we have.
Very cool.
Yep, that is one.
Yeah.
Yep.
Nice. Mason found one floating in the water. So I guess after it has taken on so much salt that it just gives up and goes on. And at that point, they find a new sacrificial leaf?
Correct. Yes.
All right. And we have a hello from the crowd, Brigitte. No, on the...
Oh.
Hello. Hey, Brigitte. Welcome to Science Saturday. So happy to have you here. And we do have like a 1 minute delay. So in a minute, Brigitte will know that we love her.
I also wanted to add, so along with those ecosystem services, like why are these trees so important? So yes, they're plants. They're able to suck up carbon dioxide from the atmosphere, which is really, really, really good. But they do a lot more, which makes them super important. So these trees, you usually find them growing along the coastline, and they're that first line of defense to help us be protected from storm surge, which is an impact from hurricanes. They also protect us from the wind energy that is created through hurricanes. They also help to filter the water. These roots, which we'll eventually get to take a look at, although they are great at providing habitat for marine animals, they're also great at trapping trash.
Ooh. So
luckily for us, there's no trash here.
Right, no trash here. But I think this is really cool, actually, because as we're standing here, some little baby waves are coming in from the opening of Brewers, and as they hit, range key and these mangroves and the little, protective system set up here, the water here is barely even moving. We've got a little bit of wind chop coming in from the land, but this is like a little miniature version of how they are protecting us. We got another hello from Marilyn and Liam.
Good morning.
Hey. Yeah, so I think this is really awesome. I'm sorry, Howard, I interrupted you because I don't know if you guys know, but my goal in life is to interrupt Howard as many times as possible in any situation. So we were talking about...
Well, I'll pipe in too, actually, Kitty, because we do have a question from the audience. So Liam would like to know how exactly mangroves filter water.
Ooh, that's a really awesome question.
I might have to go on Google for that one.
It sounds like Liam's mom might not already know the answer.
I should know this one, but I may have to resort to Google to get that answer for you.
So what are the mangroves filtering out of the water?
So normally, there are filtering that debris that would have been caught in them, but they're also filtering is any sediment. So any dirt that may be washing along the shoreline. So they'll do a good job of filtering that and keeping it in that vicinity so that ultimately further outshore, we would have we would have corals. And so we don't want any of that dirt and sediment to end up on the corals.
Yeah, no.
So these mangroves do a good job of keeping that sediment and dirt here and not out there on the corals.
All right.
We do know, I'll add this, we do know that a lot of that is due to the fact that they have this incredible calming effect on the water, right? That allows the water flow to slow down and essentially allow that dirt to settle out of the water and not transport further out. So yeah, I think, you know, at the very least, we do know they have this very, very powerful physical ability. And in fact, I mean, I see in the background there, you know, we have our nursery here, but we have mangroves all along the shoreline, all over, like you said, St. Thomas, St. John, and St. Croix, and they grow pretty expansively once they're on that shoreline. Is that right?
Yeah. So I mean, if Kitty could pan the camera around behind where that boat is, all along here, these are all mangroves, and they're all so along the left side we have all of the red mangroves, and then on the right side we have mostly white mangroves.
So for those of you who haven't noticed the airplanes in the background, that is the runway right there. And so we have this amazing mangrove system right next to the St. Thomas Airport, which we would like to keep there.
Yes, please.
All right, I had a question. Oh, I had a comment. Surprise, surprise. So I just want to say that I think it is really cool that, you know, Joe, you said that the mangroves have this calming ability in the water, and I would like to suggest that we call mangroves the Zen trees of the ocean or something. Because if you think about like them calming the water coming in, them protecting the shorelines, I think that's a really cool thing. And I also think that we have some homework to do to look up more scientific information on how mangroves filter water.
Yes,
well, why don't you guys keep going with what you can do in the field, and I'll use the studio here to kind of get a better question to that that filtration answer.
All right.
So you guys keep going with what we're going to be doing in the field today.
Yeah.
Awesome. Yeah. So I'll put in front the camera. So these are number tags. Each of these mangroves has one of these numbered tags. So when we come out into the field, and we try to do this once every year, because it's a lot of work to assess the health of all of these guys. So each one of these mangroves should have a number tag. And what we'll do is we'll come out and we'll collect specific health data on each of the mangroves. So we can look and say, mangrove number 126, last year, it measured at 40 centimeters in height. And this year, they've grown 20 centimeters. So now they're all 60 centimeters high. And so that's one of the things that we look at for when we are measuring the health of the mangroves. Zola has the data sheet.
Ooh, data sheet. So this morning, Mason and I were talking about data collection and what kind of data we might be collecting. So let's get over here, and Zola, can you let's explain to Mason, come on, explain to Mason about what kind of data we are collecting. Oh, this junior scientist came prepared with his mechanical pencil that I got him for Christmas. Not the only thing, I'm a good aunt. There were many mechanical pencils and, you know, other stuff. All right.
So as Howard mentioned, there are the little tags. So first of all, you take down the tag number, you know, to record which mangrove it is, and then whether it's still alive or not. Hopefully it is.
Right.
Also the height, as you mentioned, how much it grew in centimeters, the leaf count, the stem diameter, number of crop roots, crop root length, number of branches, and a lot of other information.
That is the scientific term. All right.
We like data.
Yeah, so data is really cool. And actually, Mason has one of the things that I got him for Christmas was the BioBlitz book scavenger hunt from the St. Croix Environmental Association. Before we start collecting data, Mason, do you want to tell us a few of the things that you have found in your book or that you're still looking for that we might find today?
Well,
I'm getting close so we can hear you.
In the books, there's a whole section on mangroves, and I haven't actually found any because I haven't really been to any mangroves yet.
All right, so what are we going to mark off in the book today? Do you remember what kind of mangroves Howard said these were?
White mangrove?
What?
Sorry, I wasn't listening. What was the question?
So we're listing off what species Mason might be able to check off in his scavenger hunt today.
Yep.
So what kind of mangroves are surrounding us today?
So right in front of us or behind me, these are all red mangroves.
Red mangroves.
Rhizophora mango.
I remember red and white mangroves.
Right behind you, I believe this is a white mangrove or a cottonwood. Nope, this is a white mangrove. So some of you look for the seeds. That's how I usually am able to identify them. So the white mangrove has these particular seed pods. The black mangrove has seed pods that look almost like lima beans. They're really big. With the red mangroves, their seeds are very obvious. They're very they're elongated in shape. And there's actually one in the water here.
Ooh, yay!
But also one of the really cool things, these are all protected by the Virgin Islands Code. So you can't do this. But on the inside of the bark of the red mangrove, it's actually red in color.
Oh.
But again, you cannot chop these down. You can't harass these trees in any way, shape, or form without a permit from DPNR.
And to be clear, what we are doing today is not harassing the mangroves. We are following their Zen nature and having a calming influence and taking information on them. So really quick, before we get into the data collection, our favorite scientist from afar, Joe, has an answer for Liam's question.
Yeah, thanks, Kitty. First of all, just a quick shout out. I see that Karen's also joined us. Good morning, Karen. As
Hey,
well
Karen.
as Marilyn mentioned from earlier that Zen trees equal filter negativity, which I think is a perfect transition to what we're about to talk about, how exactly these mangroves work on filtration. So Kitty, if you can, I know it's your phone, but if you can get close to those roots, I think we can talk a little bit more about how exactly they're doing this. So speaking of filtering negativity, when we're talking about filtering out salt, what we're actually talking about is filtering out ions, charged particles that are in the water. So we have these ions that are floating all through the water. That's what makes things taste salty. When we eat salt, those are charged particle ion, sodium and chloride together. So what actually happens within these mangrove roots is there's a series of layers that scientists have peeled back and looked at through special tools. And what they see is that these roots have special pumps that actually pump in those ions into their roots through a series of layers and slowly concentrating them more and more and more further inside of them. And what also helps is ions tend to want to kind of be together, or it helps with water movement based on if there's an imbalance of where the ions are. So between those two things, the mangroves concentrate and concentrate and concentrate these charged particles, pulling them out of the water and pulling them into themselves that they can then extrude out either underneath the leaf, like what Howard was mentioning, or using the sacrificial leaves. And that helps to actually do that filtration. So they have these really tiny microscopic pumps to do it, which I think is really cool.
That is wild. All right.
Awesome.
I love our new model of Science Saturday where Joe is our studio manager researching everything for us and I get to play in the field. We will take turns.
Yeah, you're going to have to bring me in the field every once in a while, but yeah. I may or may not be in pajama pants right now. So science in pajama pants, science in ankle deep water. We get to do both here.
Yeah. All right. So I think that science in pajama pants is a perfect segue to data collection in shorts. So where are my data collecting scientists? You ready?
Sure.
All right. So Mason, you're going to help Zola.
Okay, so Howard suggested this one.
The scientists in the natural habitat are trying to read a ID number.
Okay, so we can go with
So
this
that's
one.
8.
Oh, that's 8. Okay, so you just write down 8.
So for tag number in the first column, it's number 8.
And then yes or no if it's alive. So yes.
So this mangrove is clearly still alive.
Alive.
And then what's the next?
Height in centimeters.
For all of our measurements, we use the metric system. So we measure everything in centimeters, not inches.
60 centimeters, 60. And then the next column.
Yep. So for leaf count, what we were doing is we would sit here and count every single leaf.
Woo.
As these have grown, you can tell there's a lot of leaves. So what we'll do is we'll just say, is this more than 50 leaves? And we'll just put it in a category, yes, this has more than 50 leaves. Instead of us having to sit here and count each individual leaf.
It's a lot of leaves.
We will be here all day and maybe into tomorrow.
That's what you call job security. Oh.
Oh wait, so that was actually.
Oh.
Yeah, it's
Oh man.
So at that point, what do you do, Howard? You remove the tag and put it on another.
So right now we don't have another mangrove to replace that one with yet. So we'll leave it here for now. And then once our nursery up on land, once we have mangroves that are ready to replant, then we'll replace that one.
So I think that this is actually a really good teaching moment, because even though that one individual mangrove has died, it is still providing service. So, so guys, I know that I'm getting word that our sound went out for a second there. So, if we get closer to these, we can see that there are a few trees together. And the one that we are looking at, number 8, is actually dead. And so it is surrounded by very healthy live ones. And you can see that the roots are still planted into the water, into the sand, substrate,
yep.
into the squish. But those roots are still providing a service by, calming down the water. And we have a great question. How do we know it's dead?
So as of right now, there are no leaves on there. So the tree itself would not be able to photosynthesize and produce any energy. However, there have been rare observances where a new shoot will reemerge after what looked like a dead tree. It eventually regrows another stem. So that's part of the reason why we're leaving it, on the off chance that the stem is able to regrow.
Right.
If Kitty, it might be a little hard to see this, but on this same one that's dead, on the very last root in the back, there are actually barnacles on that root. So even though the tree may be somewhat dead, there are still animals that are on that root still living.
So this is important for anybody who's, looking at why we don't clear mangroves after storms. As Howard said, there's a chance that it can come back. And so it may have lost all of its leaves in a traumatic event like a hurricane, but they can still grow back. Also, even if it is in fact dead, it is still providing ecosystem resources. So I think that that's really important to remember. Number 8 has some barnacles living on him and is standing up with his brothers, calming the water, providing Zen services.
And that's a good point that you bring that up. So if you notice, so I can give you a little bit of history behind why we chose our planting method. So if you look here, this is this looks like number 122. So number 122 is planted all by itself. But here we had number 8 and 2 other mangroves that were planted in a group. And so part of this, the theory behind this is that when the mangroves are planted together, they are able to share the same stresses together and help reduce the stress of the overall colony together. And so they actually end up thriving and surviving so much more better when they're put together in a group. However, if you plant them in groups in excess of 3 or more plants, or 4 or more plants, they usually end up tending off to die a little bit quicker, which is why most of the clumps that we have here have no more than 3 per cluster.
Man, these are some serious life lessons today. Get yourself a good circle of friends, not too many because you don't want to crowd yourself out, but a nice strong group can help you all grow together.
Howard, this does make me ask, do we have a lot of these mangrove nurseries in the territory?
I don't want to misspeak. This is probably one of the few that I know of. I know we've given mangroves to other, I guess, organizations throughout the territory, and so they have been planting mangroves. Our Youth Ocean Explorers summer program students on St. Croix were able to do some mangrove planting with the National Park Service at Salt River Bay. So there are efforts popping up every now and again, but we definitely need more places like this.
But this is your nursery
This
and
is
your
UVI's,
mangrove babies.
Yes, exactly.
Okay, so we got way off topic from collecting data, but that's okay. So at this point, are we going to pick another number and collect the data on that one?
Yeah.
So we can get through the whole service? Service? Nope.
Through the data sheet. So
Through
we
the
can do
data
this
sheet.
one, 'cause this one has flowers.
Six.
206. Well, this one has flowers.
206, you said?
Yes.
All right, 206, data keeper. Ooh, look at that amazing job. I can't see my screen. Hey,
Kitty, are you worried about getting that paper wet? You're right there in the water.
Are we worried about getting this paper wet, guys?
Actually, no, we are not. This is actually waterproof paper. So it's not 100% waterproof. So if you splash a little bit of water on it, it's totally fine. The paper will not get wet. However, if you completely dunk it in water, this will get wet.
This will get.
It has an oily sheen on it, which helps to repel some of the water.
Cool. So this is super special scientist in the field data collection waterproof paper.
Yay, science!
Yay, science. Okay, data.
Okay, cool. So this is about 90 centimeters. Okay, it's alive. Yes.
We're sure this time.
Yes, definitely. 90. And we definitely have
A lot of leaves.
a lot of leaves.
So you can just put more than 50 for leaves. So we know this one is definitely A-okay when it comes to being able to photosynthesize and make energy.
Oh yeah. Oh, flowers. They're really pretty.
I don't have the...
Howard, could you tell us the importance of the flowers that you're seeing? You said you were excited about that earlier. You're saying it's really exciting that they're flowering.
Yeah. Howard, why are flowers so exciting?
So this is great. So these are producing flowers, and hopefully those flowers will turn.
Sorry. I just put my hand in front of the camera trying to adjust myself.
So with these producing flowers, hopefully those will turn into seeds, and then we'll be able to replant those seeds and have more mangroves to distribute throughout the territory. So these have flowered before last year, I believe, but they didn't actually go to producing seeds. Some of them actually do have the starting formation of a seed. I don't remember exactly which ones, but some of them in here do have seeds.
Oh, Zola saw one?
Zola saw one.
No, maybe. Oh wait, this one.
Yep. So that's.
I found it.
Yep.
Where's my
There's another
hand?
one right here too.
Oh, I'm apparently sorry, guys. Apparently, I'm really bad at finding my own hand on the screen. I did have coffee today. Super cool. Did you see another one?
Yep. There's another one right here.
Woo. See, I can find your hand. All right, so that's really cool. So that is evidence that these guys are healthy and strong enough to continue reproducing.
Exactly.
Now, do mangroves have to be pollinated like other species?
Yes, they do.
And what do you think pollinates them?
Is that a question for me or for the audience?
I don't know. Let's go to the audience. What do we think pollinates mangroves? Who is going to look at this flower and be like, oh man, there's some deliciousness in there. Let me get a taste.
I'll give you all a big hint. They make a buzzing sound.
I'll remind you guys that we do have a bit of a delay.
Oh yeah, we have a delay, so we won't know the answer.
but I will let you know if we get anything in the comments answering the question, what is the best pollinator for mangroves? But I'll let you guys know if we get anything.
Yeah.
And if not, we'll tell you guys by the end if you haven't yet.
Yeah. All right. So once again, we interrupted the data collection, and we're gonna go back to Zola.
So the next is how many crop roots. So maybe about 7, 1, 2, 3, 4, 5, 6. This is a crop root.
Yeah, that's a crop root.
So 7
crop roots. Oh, the sun's coming out.
Can you remind us the prop roots? That's what holds the mangroves in place and also brings in nutrients, right?
Exactly, but they also create this net-like structure, and that's what allows the mangroves to provide shelter to various marine animals. So if you're a little baby fish and you're looking for some place to hide so that you can't be eaten by a larger fish, those roots will be able to provide you with that shelter that you're looking for.
So we're looking for lots of prop roots.
Yeah.
Yes.
Okay, so the next one is number of number of branches.
So now we're counting the branches. So those are coming off the top and holding the leaves.
Let's just say 10 plus.
10 plus.
10 plus.
So we're looking at the number of plants per hole. This one has, I believe, 3. One is dead. That was number 8. So it has 3 in there right now.
So that you earlier we were talking about how them being grouped together helps keep them supporting each other. So I can see why that's important. What about the other pieces of data that you're collecting? Why is each piece important, and why are we collecting this data as opposed to other possible random numbers?
So as you had mentioned before, and there's a play. Okay, so
Well, that's okay. Oh, go ahead. Sorry.
So part of the reason behind why we're collecting this specific data is it allows us to know exactly how healthy these mangroves are. So if they're able to, well, I should probably backtrack a little bit. So them having to put salt and excrete the salt out of them requires energy. And so if they're not able to excrete salt, then they're not able to grow because they're not producing enough energy. And so part of this is if they're able to grow and have all these leaves and they're able to increase their height, then that means that they're using energy efficiently, they're growing. And so we want to make sure we capture the number of leaves that they have, how tall they are, because we can see differences in the number of leaves and their overall height, whether or not they're flowering. That lets us know if they're putting energy into reproduction. So there's a lot of reasons. Once we get through with the data sheet, there's some other really cool data that we look at. And I think Jervon was going to talk about that, but in a few minutes.
Okay. All right.
Well, before we go any further, I'm going to interrupt the data collection one more time. We did get a response to that question of what's a good pollinator. Liam said the answer may be butterflies.
Ooh. Butterflies. So I think that's really interesting because a lot of people don't think about how many different types of insects are pollinating. So I think that's definitely one of them. What else do we have?
Karen commented with what looks to be a bunch of bumblebee emojis. So how about bumblebees or any kind of bee?
Are bumblebees one of them too?
So most of those insects that fly, bees, butterflies, those would definitely be good pollinators for our mangroves.
Awesome. Good job, guys.
Are insects the only pollinator?
No, they are not. Sounds like
Mason just said.
Oh.
Another one.
Yeah.
Hummingbirds, yeah. So not only insects. So
I don't know if it's pollinating, but spreading the seeds by animals that you then drop them out in different places.
Oh yeah, so that's actually really interesting. Do any animals feed on these?
Yes. You want to?
We know that iguanas sometimes snack on mangrove propagules. I think some birds try to test them out, but that just doesn't work.
Predation, snacking.
So we do
Evidence.
have.
Welcome to CSI Science Saturday. Sorry.
I'm trying to remember. So there's a species of mangrove crab. I think it's Aratus pisonii. So those
yes.
mangrove crabs do live here. We have seen a number of them in our mangrove nursery, and they do eat the leaves. And they create these little burrows, and they will take the leaves and bring them back into their burrow to forage on them later on during the day.
Cool. Cool.
Yeah, they're these little black crabs with like yellowish spotting on their backs.
I saw a little hole in the sand.
All right, guys, I am taking advantage of another ecosystem service of the mangroves, which is to provide shade so that my phone doesn't overheat again. And so we're going to take, oh man, my hand is like 2 degrees cooler in here.
Yeah.
I mean, like on the
This
All
is a
right.
clean cut. I don't
So
know.
while we're hanging out in the shade here, I'm glad that nobody is recording me because I'm just like crouched between the propagule and the roots looking for shade. Thank everyone who's with us so far. Dara, hey, I just heard that you are on.
I'll tell you what, Kitty, why don't we take a break and we can talk just a little bit about that 360 photo and video that that we had earlier. That might give your phone a little bit of time to cool. So
yeah, absolutely.
Yeah, so maybe if you can get Howard to introduce it, or I can just show everyone what we've got going on right now.
All right,
If
so
you're-
actually Howard is holding up the 360 cam right now. Ta-da! All right, I'm feeling pretty cool. So this is the 360 cam.
Right. So
That's all I got.
so I'll tell you what, Kitty. Why don't you keep cooling off, and I can show everyone now what that camera has the ability to do. So when we say 360, we mean that it takes an image of every single thing around it. And so Howard and Jervon have actually been using this to capture this nursery through time. So what I'm going to do now is I'm going to go ahead and share my screen so everyone can see what one of those photos might look like. So let's see here. So right now I'm sharing an application. It's called Panorama Viewer. It's a system that's online. Now, what you can see here is this is right where we just were. So here's the Mangrove Nursery. This is a photo from another day that Howard and Jarvan were out working in the nursery. But what you can see is what's really cool. You know, even if you can't necessarily get to the nursery, you can look all around. You can see all up on the sky. You can see the boats out at Brewers and the rocks. And so you can see everything within this one photo, which is really cool. And Howard and Jarvan have been taking a lot of these photos through time as the mangrove nursery grows and gets larger and bushier and full of more leaves and prop roots and everything. You can see this is a much earlier time. And so I think that's personally an incredible tool. And these are actually all available on the Center for Marine and Environmental Studies Facebook page. If you go onto that page, I will post a link in the comments once we're done here. So you guys can check all of these out. There's a lot of photos and some really cool videos as well. And so the next thing I'll show is actually we can take this technology and not just look at images. We can even look at videos. So let me get this pulled up here. Okay. And we need that out of there. And if we look here, I've got these playing now. This will actually play if you have a Windows system, it'll play automatically. I'm just going to put this on a repeat. But so what you can see here now, we can see how that water, like what we were talking about earlier, is right there in the mangroves. You can see these prop roots, like what we were just measuring. And you can see how Howard actually, this is from another day, is kind of going through, measuring, looking at, taking observations on these mangrove nurseries. So this is something that's a really cool technology. Again, this is on the Center for Marine and Environmental Studies Facebook page. So if you haven't liked that page already, we do post a lot about the mangrove nursery. Howard does a lot of that work, and Jarvan as well. So definitely check that out when you have a chance. And yeah, and we're collecting more of this today. So keep on the lookout for some Science Saturday photos and videos later this week, I think, or depending. So I'll pass it back now to the team in the field. But that's some of the studio science that we're having a lot of fun with over here.
All right, awesome. Thanks, Joe. So I'm gonna wade out a little bit deeper now. Oh, there's a fish. Sorry, there's actually lots of fish, but that is the biggest fish I've seen this morning. So we're going to talk about some of the other data that is collected out here. And I'm going to put my back to the sun so that we've got a really nice view. All right. Hey.
Hi.
So what else? What else do we have today?
So Howard and I have been working on a project using these GoPros. It's called Mangrove Spy USVI.
Ooh.
And so we're using these GoPros. We actually have 5 of them. This is just one.
Mhm.
And so what we do is we come out once a month and we place these GoPros at different vantage points around the nursery. And they're waterproof, so we put them in the water, facing inwards towards the nursery. And this actually helps us get a snapshot of all the vertebrates and invertebrates that are using the prop roots for shelter.
Whoa. So what kind of stuff have you found?
Okay, a lot. Barracudas, needlefish, pufferfish, mullet, mohara, all kinds of snappers, silver
Barracuda are my favorite fish. They are so adorable and they remind me of puppies and I love them so much. Okay, that just made my morning. I love Science Saturday.
We've also had a lot of invertebrates. So we have a lot of crabs, sea urchins especially.
Ooh.
Sometimes we even have wading birds, so egrets and herons that are actually catching fish that are heading throughout the nursery as well.
Okay.
And what's really cool about the Mangrove Spy USVI project is it's going to be hosted online. So the pictures that we take, we're going to upload to a website called Zooniverse.
Zooniverse.
And so once we upload those photos, once the project is launched, it's coming soon, anyone at home will be able to log on and look through the photos and help us identify and catalog the biodiversity of things.
Oh, super cool. So that's like, I remember when Snapshot Serengeti was like the cool thing to do. And this will be awesome to have a local version right here in our backyard, your backyard. So that's really exciting. So when we learn about that, we will for sure be posting that on our DPNR page, also on Vine. For those of you who are not on our Vine Facebook page at the Virgin Islands Network of Environmental Educators, where we share the cool stuff that everybody's doing. So that is amazing.
I actually want to share
One quick note, Kitty. I was just going to mention that Jarvan and I are rocking the same t-shirt right now. So
oh, you guys are totally twinsies today.
In the field.
And last month, Mason was wearing that shirt. So we fully support the graphic design of Refest.
Anyway, sorry, Jarvan, I didn't mean to interrupt. What were you about to say?
Oh, I was going to share, since this is Science Saturday, I'm going to share some scientific terms with you guys.
Ooh.
So when scientists assess biodiversity, there are many things you look for, but 2 of the things that we tend to look for are called species richness and species abundance. So species richness tells you how many different species are in an area, and the species abundance tells you how much of each species relatively you'll find in that spot. So those are 2 things that we'll be looking for once we launch the Mangrove Spy USVI project.
Very cool. I like that. So that is, I think that's something that's really important to think about. And I wish somebody had told me when I was younger, science is so cool. Like, I was totally the kid in class who said that I didn't like science because it felt like just memorizing abbreviations. But we did go out on a few field trips. I remember going out to the salt pond in Steer at Compass Point at one point. I think I was in 2nd grade. And it really amazes me how far we've come in sharing the funness of science with kids as they grow up. And I gotta say, these guys, have done an amazing job of helping with that. So I don't want to relive my childhood, but if I did, I would come right back and do all of these programs that are available So this is super cool. So guys, I know, Howard, you had one more piece of data. It's not lightsabers.
No, these are not lightsabers, and these are not weapons. You don't want to hit people with these.
No.
So we haven't actually started this yet, but these are called sediment corers. So basically what we would do is we would stick these and try and find a decent spot. So we would be able to dig this into the sediment.
Well, Mason, do you want to try one?
And ultimately what would happen is if we didn't hit a hard rock just now, this entire thing would be filled with sand and other types of sediment.
It's pretty squishy under my foot. So Mason, if you want to come over to my left foot, I'll move my heel because I was about to sink.
Yeah,
now,
can you
don't
get pointed down a little bit more? I want to see exactly what we're doing. You're just pushing that into the ground.
Yeah, pushing it in the ground.
There's a lot of rocks in this area, hence the reason why it's not completely covered with mangroves everywhere.
Right.
There are rocks everywhere. But basically, you would end up having sand or sediment coming all through this entire corer. And so we can look at it to see different layers or stratification of layers. So you would see some organic material. You might see some sand. So most of this, it's all black and dark in color. So this is organic material. So as the leaves start to decompose, you start seeing all of this organic material in the sand. So this is really helpful. This is really nutrient-rich sand. But it helps us to get a better snapshot, a better synopsis of what's going on, not just in the water, but actually down below in the soil.
Super cool. All right.
From the ground up. Well, I do want to mention we have a couple comments. First of all, just reiterating, Kitty, what you were saying earlier. Dara's favorite superhero duo, Howard and Jarvan. Kitty is also Lois Lane on the down low. And also there has been a link posted to that UVI CMES page where those photos and videos are I mentioned earlier, as well as just a reiteration, learning in the field while in the comfort of your own home, coming from the pajama pants scientist, I say that's always pretty fun.
Love it.
Yeah.
All right. So as I'm looking around and enjoying the view, I did notice we are surrounded by a little bit of a man-made wall. Howard, what's up with that? Oh, distraction. Look at Smush's core, Mason's core. Ooh,
oh, wow.
Awesome. So sometimes you may have little critters that are in there. So there's a lot of little tiny invertebrates that are sometimes found in that soil. There's a lot more scientific stuff that happen behind the scenes in an actual lab setting to actually analyze this. But in most cases, you may see some layering, some stratification. You might see some leaves.
Oh, we can just like squish it.
You can squish it through and you can see all the different sand and different types of dirt. So there's a lot of sciencey and cool things we can do just by looking at this. Call it mud.
Mud.
Yep. But you did have a question about that.
Oh, yeah. And also we have another question about, so when you're in the lab, what are you going to find in those? What kind of things are you going to measure?
So we're still working out those details. My responsibility for right now is just tending to these. We have other persons who will be looking at this soil concentration.
So that's a really important part to learn about science is we have scientists with different expertise and different passions. And I'm a big fan of having different passions and getting together with people with different passions and sharing and doing all sorts of fun stuff. So here we have photography and data collection and botany and engineering.
To a certain degree, yeah.
As we're going back to our wall, you know, what is, I keep on just, you know.
Yeah, I'm glad you brought that point up. So one of the things the researchers do is they take that mud and they stick it in an oven.
Ooh.
And that allows them to be able to tell exactly how much carbon is in here. I am probably not the best person to be in charge of an oven, so I will not be the one doing that. So it's better for me to be out here with these mangroves and tending to them, and we'll have more professional people in the lab with the oven to burn the soil.
To burn the soil. All right, that is a scientific term. Yes. Burning the soil to find the carbon. That sounds like a Dr. Wilson Grimes thing.
Yeah,
finding the carbon. All right, so we're going to go back to our wall around here because I keep on getting the feeling that it's important and then I get distracted. because shiny things. Woo! All right, what do we got?
So we basically engineered
Engine.
a wall created of, I guess, coral rubble, some cinder blocks, really large rocks. And so this wall, part of it was designed specifically to help reduce wave energy. So when we plant new mangroves, we don't want really large waves to come over and wash all of the mangroves out and undo all of our hard work. So we've created this wall to kind of help reduce that wave energy and allow our mangroves to thrive. It's also served another purpose. So in between all the spaces that this wall has created, there's a whole bunch of marine animals that are now living inside this wall. So there's a lot of fish, there are urchins every now and again. We have seen clams. There's a whole bunch of different, you'll find different things almost every day when you come out here.
Ooh, clams. Okay, so totally unrelated. I saw a post recently by one of our amazing scientist friends on St. Croix, Kai, who found in Altoona Lagoon a cockle. And she ate it, and she said it was delicious. Do we have cockles on St. Thomas? And this can go to the audience as well. It looked just like a clam, like I used to have on vacation in Long Island. But I'm hungry. Is it lunchtime yet? Those who know me knows that this is how we know it's almost time to go, because now I'm talking about food. So on that note, do we have any parting words on what is our take-home message today? Why do we love these? Why do we want to protect them? How do we protect them? That could be a whole new Science Saturday in one sentence.
So I know we wanted to change the name of the mangroves to this Zen thing, but I've always wanted to change them to the tree of life. So these trees help support life. So they are absolutely phenomenal. They are amazing. They are so fantastic. I mean, just being out here, your whole energy just becomes more positive. Being out here is very relaxing. So we want to definitely protect these trees because they do a lot of really good things for the environment, not just for the animals, but also for us too. We do on occasion have field trips where we bring school groups down here, but our building is currently under construction. Once that's finished, we'll be able to start resuming our operations to have school groups back down here. So we do have volunteers that can help us collecting data, helping us planting. So there's a lot of opportunities for the community to get involved. And as soon as we're able to do that, we'll let everyone know.
All right, awesome. I'm going to flip around back to my face for just a minute. Hey. So from the field scientist to the pajama scientist party, I want to thank everybody for coming out today. Howard is creeping behind me, searching for a fish. Cool. All right, guys. So as always, thank you so much. I really appreciate everybody hanging out with us today on our first Science Saturday of 2021. Woo, woo.
Yes, absolutely. And Kitty, before we go, I did just want to make a point for everyone who's joining us on Science Saturday to wish Kitty a happy early birthday, or if you're watching this tomorrow, a happy birthday to Kitty. Of course, she's been the lifeblood of this program and our always favorite scientist in the field, no matter what it is we're doing or who we're hanging out with. So very happy early birthday to Kitty. A couple more comments. Dara also shared the Virgin Islands Network Environmental Educators Facebook page. Another great way to keep up with a lot of the environmental activity that's happening throughout the territory. I encourage people to check that out. Also mentioning how this is a much more productive reason for building a wall would be a mangrove nursery. So I think if that's everything, I would love to just close on a happy early birthday to Kitty. I'm not seeing any other questions here. Please check out those Facebook pages when you have a chance. And everyone have a great month. We'll see. Well, actually, wait, before we go, Kitty, what are we doing next month? You get to introduce it because I'm too excited about it.
Next month, we are going to be talking about coral disease. That does not sound so celebratory, but we have been doing amazing work in the territory. Joe has been doing amazing work in the territory. We're going to be joined, I believe, by Sonora, who is a recent graduate of the UVI Master's Program, and she's got some activities for us to learn about the importance of coral, which you know we love coral, and the stony coral tissue loss disease. So we will see you guys again on February 13th at 10 a.m. somewhere in the field, because this is just the most fun way to do Science Saturday. If only I could keep a coffee shop with me. Lattes, we miss you. All right, everybody, have a wonderful day. Bye. Bye.
Have a great one, everyone.